Hey everyone, in today's video I'll be working through a series of questions on integration by substitution, so grab a pen, some paper and a calculator and let's get started. In the first question we are told to use the substitution u equals e to the power of x plus 4 to show that the integral between the limits of 0 and ln 6 of 2e to the x plus 3 divided by e to the x plus 4 equals the integral on the right. So the first thing I'm going to do using this substitution is make e to the power of x the subject, which is simply u minus 4. And if we differentiate both sides of our substitution with respect to x, we get e to the power of x. So du equals e to the power of x multiplied by dx. So dx equals 1 divided by e to the power of x multiplied by du. And given as e to the power of x equals u minus 4, we can write this as 1 over u minus 4 multiplied by du. And we also need to determine our new limits. So we know when x equals ln 6, u equals e to the power of ln 6 plus 4. And remember that e to the power of ln x is just x, so the first term is 6 plus 4, and that equals 10. And when x equals 0, u equals e to the power of 0, which is 1, plus 4, and that gives us 5. So we can write our integral with the limits 5 and 10 of 2e to the power of x. So remember, e to the power of x is u minus 4, so we have 2 times u minus 4 plus 3 divided by e to the power of x plus 4, which is simply u, multiplied by dx, which is 1 over u minus 4 multiplied by du. So we have 2u minus 8 plus 3 minus 8 plus 3 is minus 5, so I can just write minus 5 instead, divided by u multiplied by u minus 4 du. So a equals 5, b equals 10, c equals 2, and d equals minus 5. But you don't have to state this, but this is just so that it's easier to identify what each of these constants are. In the final part of this question, it says, hence, using algebraic integration, show that the integral on the left equals p ln 2 plus q ln 3. So hopefully you identify that we can split this integral into partial fractions. So we have 2u minus 5 divided by u times u minus 4, and we can write this as a over u plus b over u minus 4. And in order to write the right hand side of this equation as a single fraction, we need to multiply the denominators. So you'll notice that in order for the first fraction to have a denominator of u times u minus 4, we need to multiply the numerator a by u minus 4, and for the second fraction to have a denominator of u times u minus 4, we need to multiply b times u. So 2u minus 5 equals a multiplied by u minus 4 plus bu, and in order to determine a suitable value for a and b, we need to substitute a suitable value of u into this equation. So if I want to eliminate a, I can state that u equals 4. Therefore, I have 2 multiplied by 4 minus 5, and that will equal 4 times b. So 4b equals 3, therefore b equals 3 over 4. And when u equals 0, the left hand side simplifies to minus 5, and the right hand side becomes minus 4a. So a equals 5 over 4. So we can write our integral as 5 over 4u plus 3 over 4 times u minus 4 du. So we have 5 over 4 multiplied by 1 over u plus 3 over 4 multiplied by 1 over u minus 4 du. And by factorizing 5 over 4 from the first term, I have the integral between 5 and 10 of 1 over u du plus 3 over 4 multiplied by the integral of 5 and 10 of 1 over u minus 4 du. So we have 5 over 4 ln u plus 3 over 4 times ln modulus of u minus 4, and that's going to be solved between the limits of 5 and 10. So after substituting our limits, we get this. So we can write this as 5 over 4 ln 10 plus 3 over 4 ln 6 minus 5 over 4 ln 5 minus 3 over 4 ln 1. And hopefully you identify that this gives us 0. And given as we need to write our integral in this form, I'm going to write the first term as 5 over 4 ln 2 times 5 plus 3 over 4 ln 2 times 3 minus 5 over 4 ln 5. And given as ln AB can be written as ln A plus ln B we can write the first term as 5 over 4 ln 2 plus 5 over 4 ln 5 plus 3 over 4 ln 2 plus 3 over 4 ln 3 minus 5 over 4 ln 5. And we can see that these terms cancel, and when we add our like terms, we get a final answer of 2 ln 2 plus 3 over 4 ln 3. In the next question, we are told to use a substitution x equals 4 sine theta to find the exact value of this integral. So given as x equals 4 sine theta, we can state that dx by d theta equals 4 cos theta, and by multiplying both sides by d theta, we can state that dx equals 4 cos theta d theta. So we're going to substitute this into our integral, and given as we have x squared in our integral, we can write x squared as 16 sine squared theta, and the final step is to determine the new limits. So when x equals 2 root 3, 4 sine theta equals 2 root 3, so sine theta equals 2 root 3 divided by 4, which is root 3 over 2. Therefore, theta can be obtained by taking the sine inverse of root 3 over 2, and that gives us pi over 3. And when x equals 2, we have 4 sine theta, and that equals 2. So sine theta equals 2 divided by 4, which is a half. Therefore, theta equals the sine inverse of a half, which is simply pi over 6. So we can write our integral with a lower limit of pi over 6 and an upper limit of pi over 3. And now we have 1 divided by 16 minus 16 sine squared theta. And I'm going to raise all of that to the power of 3 over 2. And where we had dx, we can replace that with 4 cos theta d theta. So the next thing we need to do is factorize 16 to the power of 3 over 2 from our denominator. So we have 16 to the power of 3 over 2 multiplied by 1 minus sine squared theta to the power of 3 over 2. And when we divide 4 over 16 to the power of 3 over 2, we get 1 over 16. So we can multiply that by cos theta divided by 1 minus sine squared theta to the power of 3 over 2 d theta. And remember, that's our integral, so that will be between the lower limit of pi over 6 and the upper limit of pi over 3. So we have cos theta divided by cos squared theta to the power of 3 over 2 d theta. And given as cos squared theta is the same as cos theta all squared, if we raise this to the power of 3 over 2, we can multiply the powers. So I'm just going to write 3 over 2 here, giving us cos cubed theta. And after simplifying this, we have 1 over cos squared theta, which we can write as sec squared theta. And when we integrate sec squared theta, we have tan theta, and we're going to solve this between our limits. So we have 1 over 16 multiplied by tan of pi over 3 minus tan of pi over 6, giving us 1 over 16 multiplied by root 3 minus root 3 over 3. So the final answer is root 3 divided by 24. In the next question, we are told to show that the substitution u equals tan x transforms this integral to the integral of u divided by k plus u squared to the power of n du, where k and n are integers to be found. So we know that u equals tan x, so du by dx gives us sec squared x. So by multiplying both sides by dx, we have du equals sec squared x dx. So dx equals 1 over sec squared x du. And given as u equals tan x, u squared is tan squared x, which is the same as sec squared x minus 1. So sec squared x equals u squared plus 1. So we can state that dx equals 1 divided by u squared plus 1 du. Therefore, our integral becomes u plus u cubed divided by 4 plus sec squared x, which is just u squared plus 5 to the power of 3, multiplied by 1 over sec squared x, which is u squared plus 1 du. And after factorizing u from the numerator, we have 1 plus u squared divided by u squared plus 5, all cubed, multiplied by 1 over u squared plus 1 du. So hopefully you'll notice that this term and this term cancel. So the final answer is u over 5 plus u squared all cubed du. In the final part of this question, it says hence, find this integral. So the first thing we're going to do is write this integral as u multiplied by 5 plus u squared to the power of minus 3 du. So hopefully you will notice that you can use the reverse chain rule. So if I state that y equals 5 plus u squared to the power of minus 2, and I differentiate this with respect to x, I need to multiply the coefficient of my bracket by the power that my bracket has been raised to. So I have minus 2 multiplied by 5 plus u squared to the power of minus 3, and then I need to multiply that by the derivative of my brackets, which is just 2u. So this simplifies to minus 4u 5 plus u squared to the power of minus 3. So when we integrate minus 4u times 5 plus u squared to the power of minus 3 with respect to u, that gives us 5 plus u squared to the power of minus 2 plus c. And given as we need to integrate this expression, we need to divide this term by minus 4. So our answer is minus 4 times 5 plus u squared to the power of minus 2 plus c. And using our substitution, the final answer is minus 1 over 4 multiplied by 5 plus tan squared x to the power of minus 2 plus c. In the final question, we are told to use a substitution u equals 3 plus cos theta to show that this integral equals a root 3 plus b. So before we get started, I want you all to bear in mind that sine 2 theta is 2 sine theta cos theta, and given as u equals 3 plus cos theta, du by d theta equals minus sine theta, so du equals minus sine theta d theta, so minus du equals sine theta d theta. And using this substitution, we can state that cos theta equals u minus 3. And in order to determine our new limits, we need to substitute theta as pi over 2 into our substitution. So u equals 3 plus cos of pi over 2. And when you put that into your calculator, remembering that your calculator must be in radians, you get 3. And when theta equals 0, u equals 3 plus cos of 0, and that equals 4. And where we have sine 2 theta, we can replace that with 2 sine theta cos theta. But remember that we can write this integral as 2 times cos of sine theta d theta all over our denominator, which is 3 plus cos theta in our square root. So we can replace sine theta d theta with minus du. So minus 2 times u minus 3 divided by u to the power of a half d theta. And in order to switch my limits, I need to multiply this integral by minus 1. So the integral is between 3 and 4 of 2 times u minus 3 all over u to the power of a half d theta. So we have 2u divided by u to the power of a half minus 6 over u to the power of a half du. And that simplifies to 2u to the power of a half minus 6u to the power of minus a half du. And when we integrate this, we have 2u to the power of 3 over 2 divided by 3 over 2 minus 6u to the power of a half divided by a half, and that's between the limits of 3 and 4. So by simplifying this, we have 4 over 3 u to the power of 3 over 2 minus 12 u to the power of a half between 3 and 4. And after substituting the limits into this expression, we have 32 over 3 minus 24 minus bracket minus 12 root 3 plus 4 root 3. So the final answer is 8 root 3 minus 40 over 3.